Now, to prove this statement is divisible by 2, remember we need to follow 4 steps. So let's go straight into it, okay? Step number 1, we need to show n is the smallest number is true for the statement first. So in this case, the smallest number is 1. So this means that n is replaced with 1. So 3 times 1 is 3, minus 2 is 1. So that becomes 5 to the power 1 and minus 3. So the answer is 2. So that is divisible by 2. Now we assume that it is true for n equal k. So in another word, we replace n with k. So that is 5, 3 lots of k minus 2 minus 3 is equal to, now if this statement is true, that means it is multiple of 2, right? So it's 2 times a number because it's multiple of 2. So I just write is equal to 2m. There you go, because it's multiple of 2. Then the next statement, it will prove for n equal k plus 1. So this means that we replace n with k plus 1. So what I do now is I just expand the bracket, okay? Plus 3 minus 2 and then minus 3. So instead of simplified, so what I do, I just rearrange it, okay? So this is equal to 3k minus 2 plus 3 and then minus 3 here, okay? So I'm not simplified, so I just rearrange it, that's all. And the reason is because I want to make 5 power 3k minus 2 as a subject. So it's easier, that's all. Now remember, a to the power of m plus n is equal to a to the power of m times a to the power of n, right? So in another word, 3 power of 3k minus 2 plus 3, this will give me 3 power of 3k minus 2 times by 3 square. That's what that meant. So now I just split it out, so which give me 3 power of 3k minus 2 times by 3 to the power of 3. And this is minus 3 out. Now, then 3 to the power of 3 is 27. So this is exactly the same as 27 times 3 to the power of 3k minus 2 minus 3. Let's go back to our assumption. So if I move this one on this side, so this means that 5 3k minus 2 is equal to 2m plus 3. So then 5 to the power of 3k minus 2 is equal to this. Okay? So which equal to 27 bracket 2m plus 3 and minus 3. So what I do now, I just expand the bracket. So instead of I times 27 times 2, I can just write 2 times 27 first, because I'm going to take the common factor out. What that is true anyway. So I just leave as it is for now. And a plus. So 27 times 3. So 27 times 3 is 81. So just write 81 down. And this minus 3. So I simplified this. 81 minus 3. So 80 minus 3 is 77. and then plus 1 is 78. So that equal to 2 times 27m plus 78. So now I just take the common factor out. That is 2. So that gives me 27m plus, so 78 divided by 2 is 39. So which is so that is divisible by 2. So therefore, we need to write therefore it is true for n equal to k plus 1. Then we just need to write the last statement. That is, therefore, the statement is true for all n greater or equal to 1. There you go. So this is how you prove divisibility by mathematical induction. Now please stop the video and try this one yourself. Now let's go through it together. So step number 1, we prove for n equal the smallest number in this case is 1. So that is, we replace n with 1. So this becomes 7. Okay, 2 times 1 minus 1 plus 5. So 2 times 1 is 2 minus 1 is 1. So that is 7 power 1 plus 5. So which is 7 plus 5. So that is equal to 12. So which is that is divisible by 12. So now we assume that it is true for n equal k. So that means we replace n with k. Okay. So that is 7 to k minus 1 plus 5 is equal to multiple of 12. So which is 12m or 12p, whatever that is. Okay, I just write 12m because it divisible by 12. Okay. Then we need to prove for n equal to k plus 1. In another word, we replace n is equal to k plus 1. So which equal to 7 to power k plus 1 minus 1 plus 5. So I just expand the bracket first. That will give me 7 to k plus 2 minus 1. And we add 5. Now, of course, I can simplify, but it's easier. We just rearrange it, and then we're gonna make 7 power k minus 1 as a subject. So we can manipulate so it becomes multiple of 12. Okay? So that is 7 2k plus 2 minus 1 is equal to 7 2k minus 1 plus 2. So which is equal to 7 2k minus 1 times by 7 squared. Remember that, okay? Because a power of m plus n, it can be written as which equal to a power of m times a power of n. Okay, it can be written like that. So this becomes 7 2k minus 1 times 7 squared plus 5. But 7 squared is 49. So which equal to 49 times 7 2k minus 1. and add 5. So now let's go back to the assumption. This means that I move the 5 on that side. 7 power of 2 k minus 1 is equal to 12m minus 5. So now I just substitute 7 2 power of k minus 1 with 12m minus 5. So just write it down. Equal to 12m minus 5. And we add 5 here, of course. Now I just expand it. So 49 times 12m, I just write 12 times 49m minus 49 times 5. So 49 times 5. So that is 245 and a plus 5. So that will give me 12 times 49m minus 245 plus 5 is minus 240. And of course, I need to take the common factor out. In this case, it's 12. So I take 12 out. So that gives me 49m. So 240 divided by 12. So 24 divided by 12 is 2. So 20. Which is divisible by 12. So therefore it is true for n equal k plus 1. So the last statement is which is right the conclusion. So therefore the statement is true for all n greater or equal to 1. Thank you so much for watching my video. Bye.